Let's begin with definite integrals requiring U substitution. First, let's recall the fundamental theorem of calculus. The fundamental theorem of calculus states that if we have an integral from a to b of lowercase f of x dx, then this is going to be equal to uppercase f of x evaluated from a to b, which is also equal to uppercase f of b minus uppercase f of a. Let's go ahead and box that in. So it is very important that we remember this theorem because we will be using this throughout this section. When your integral requires U substitution, leave the bounds off until after you have completed the integration. I'm going to highlight that part that says leave the bounds off until after you have completed the integration, and I'm also going to underline it. I'm going to double underline the part that says until after so that you remember to bring those back after you are done. Example 1, evaluate the integral. The integral from 0 to 4 of 3x times the square root of x squared plus 9 dx. Step 1 is going to be U substitution. First, what we're going to have to do is we're going to have to identify that inner function. So I'm writing down the integral without the bounds, the integral of 3x times the square root of x squared plus 9 dx. Here we can identify what our u is going to equal. Our u is going to be equal to x squared plus 9 because that's our inner function. Therefore du is going to be equal to 2x dx. Looking here at the problem, I can see I've already got an x right here next to the 3, and there's my dx. I've highlighted those in green. I'm going to divide both sides here by 2, so I have 1/2 du is equal to x dx. I'm going to draw a line here separating the work that I did in finding my u and finding what I'm going to replace for my du. And I'm going to put here that this integral is equal to 3 times the integral of the square root of x squared plus 9 times x dx. I've highlighted the x dx in green, as I have also highlighted the x dx in green in the part where I found my substitution. I've drawn a cloud around the 1/2 du with an arrow pointing right at the x dx. I've highlighted my x squared plus 9 in yellow, which represents my u, and now I drew a cloud around the u and an arrow pointing at the x squared plus 9 that I've highlighted in yellow in the integral problem. So now we can do our substitution. 3 times the integral of, here I can either choose to write a square root or I could choose to write raised to the 1/2 power. So I'm going to choose the 1/2 power because that's going to be easier to integrate. So 3 times the integral of u raised to the 1/2 power times 1/2 du. Next, we're going to have 3/2 times the integral of u raised to the 1/2 power du, because I factored out the 1/2 to the front. Now I can do my integration. This is going to be 3/2 times u raised to the 3/2 power over 3/2 plus c. We can simplify this a little bit more. So I'm going to draw an arrow here pointing at this part of the problem up to the upper right hand side of my screen, and I'm going to write 3/2 times 2/3 times u to the 3/2 power plus c. So 3/2 times 2/3 is just going to give me a 1. So I'm just going to go ahead and replace my u with the x squared plus 9 in parentheses and raise that to the 3/2 power plus c. And this is going to be equal to my uppercase f of x. So now step 2. Step 1 was the U substitution part. I've gone back and I've highlighted that step 1 U substitution in blue so that you realize that this is now a second part. And now for our step 2, we need to go back and evaluate this with our bounds. So now let's go back and look at this. For step 2, I'm going to write finish evaluating the integral. So we're going to go ahead and write down, before I write anything down, I'm going to highlight in blue the step 2 part so it stands out. I'm going to open up a set of parentheses, write x squared plus 9, close the parentheses. I'm going to raise that to the 3/2 power. I'm going to draw that long line here that goes to the side. That means we're evaluating this from 0 to 4. And now we're going to substitute. So this is going to end up being, open up a set of parentheses, 4 squared plus 9 raised to the 3/2 power minus, open up a set of parentheses, 0 squared plus 9, close the parentheses, raised to the 3/2 power. This is going to equal, open up a set of parentheses, 16 plus 9, close the parentheses, raised to the 3/2 power, minus, open up a set of parentheses, 9, close the parentheses, raised to the 3/2 power, equals 25 raised to the 3/2 power minus 9 raised to the 3/2 power, which is equal to the square root of 25 raised to the 3rd power minus the square root of 9 raised to the 3rd power, which is equal to 5 cubed minus 3 cubed, which is 125 minus 27, which is going to be equal to 98. And we're going to box in that final answer. I'm going to lasso in all the work that I have here on the right hand side, just so that we can make it a little bit smaller so that it fits a little bit nicer here in our space that we have here. So that looks much better. Good, we're going to leave it like that. Example 2, evaluate the integral. The integral from 1 to 6 of 5 over 2x plus 7 dx. So for our step 1 here, I know I said we would do U substitution first, and I am going to do the U substitution, but first what I want to do is I want to rewrite this so that we move everything that we have in the denominator up to the numerator with a negative exponent. So I'm going to rewrite this as the integral of 5 times, open up a set of parentheses, 2x plus 7, close the parentheses, raise it to the -1 power dx. Now I'm going to choose my u equal to 2x plus 7, that's going to be my inner function, and du is equal to 2 dx. And if I solve for dx, I'm going to get 1/2 du is equal to dx. So now I'm going to say this is equal to, I'm going to factor out the 5. So I'm going to have 5 times the integral of, we're going to have inside parentheses 2x plus 7, all raised to the -1 power dx. So now we are ready to substitute and do our change of variables. So this is going to be 5 times the integral of u raised to the -1 power times 1/2 du, which is equal to 5/2 times the integral of u raised to the -1 power du. Now hopefully you recall what we do when we have the integral of anything raised to the -1 power. This is going to be equal to 5/2 times the natural log of the absolute value of u plus c. Now we can go back and substitute for u what u was equal to. Before I do that, let me lasso in the work that I just did and just squish it in more towards the left so I have more space here. This is going to be equal to 5/2 times the natural log of the absolute value of 2x plus 7, close the absolute value, and then plus c at the end. Step 2, now we need to finish evaluating the integral. So I'm going to write down 5/2 times the natural log of the absolute value of 2x plus 7, close the absolute value, evaluated from 1 to 6. This is going to be equal to 5/2 times the natural log, we're going to open up a set of absolute value, 2 times 6 plus 7, close the absolute value, minus 5/2 times the natural log of, we're going to open up a set of absolute value, 2 times 1 plus 7, close that absolute value. And this is going to be equal to 5/2 times the natural log, we're going to open up a set of absolute value, 12 plus 7, close the absolute value, minus 5/2 times that natural log of, we're going to open up a set of absolute value, 2 plus 7, close the absolute value, and this will be equal to 5/2 times the natural log of 19, but the absolute value of 19 is just going to be 19. So here in reality, I don't really need to write the absolute value in this step. So I'm just going to go ahead and take off the absolute value, since the absolute value of 19 is just 19, and I'm just going to write 19. So it'll just be 5/2 times the natural log of 19 minus 5/2 times the natural log of the absolute value of 9. But the absolute value of 9 is just 9, so I'm just going to go ahead and write 9. So that's going to be our answer, 5/2 times the natural log of 19 minus 5/2 times the natural log of 9, and I boxed that in. I've lassoed all my work and I made it smaller so it would fit better in that space that we had there available for us. And now we're ready to go on to our next problem. So we're going to do some more practice, more evaluating integrals. Number 3, the integral from -1 to 0 of x cubed over, we're going to open up a set of parentheses, 2 minus x to the 4th, close the parentheses, raised to the 7th power, and then dx. I'm going to rewrite that so that what we have in the denominator is in the numerator with a negative exponent. So it's now going to say the integral of x cubed, open up a set of parentheses, 2 minus x to the 4th, close the parentheses, raised to the negative 7th power dx. My u is going to be equal to 2 minus x to the 4th. So du equals negative 4x cubed dx. I notice that I have an x cubed and a dx here in my integral. I'm going to highlight those in green. I'm also going to highlight in green the x cubed and the dx in the du that I just found. So I do have part of what I need for my substitution. I'm going to divide both sides by -4, and here I'm going to have negative 1/4 du equals x cubed dx. So I know exactly what I need to substitute to write this in terms of u. So this is going to be equal to the integral of 2 minus x to the 4th, all raised to the negative 7th power, x cubed dx. Now when I do my substitution, this is going to turn into this integral of u raised to the negative 7th power, and then in place of that x cubed dx, I'm going to substitute negative 1/4 du. So I can factor out my negative 1/4 to the front of my integral here. I'm going to draw a line here separating the work that I did for finding my u and my du. I'm going to have here this equals negative 1/4 times the integral of u to the negative 7th power du, which is equal to negative 1/4 times u to the negative 6th power divided by negative 6 plus c. So this will then turn into negative 1/4 times negative 1/6 is equal to 1/24. And this is going to get multiplied with, we're going to open up a set of parentheses, 2 minus x to the 4th, close the parentheses, raised to the negative 6th. And we're going to evaluate this from -1 to 0. So this is going to be equal to 1/24. We're going to open up a set of parentheses, 2 minus 0 raised to the 4th power, close the parentheses, raised to the negative 6th power, minus, we're going to have 1/24, open up a set of parentheses, 2 minus, we're going to have here negative 1 inside a set of parentheses, raised to the 4th power, close the parentheses, raised to the negative 6th power. Now let's try to simplify this as much as we possibly can. So we're going to have 1/24 times, open up a set of parentheses, 2, close the parentheses, raised to the negative 6th power, minus 1/24, open up a set of parentheses, 2 minus 1, close the parentheses, raised to the negative 6th power. So it looks like here we can simplify this some more. This will be equal to 1/24 times 1/2 to the 6th power minus 1/24 times 1 raised to the negative 6th power. And this will be equal to 1/24 times 2 raised to the 6th power. And then from that, we're going to subtract the fraction 1/24. And then that 1/24 was being multiplied with 1 to the negative 6, but 1 to the negative 6th power is just a 1. So if I multiply 1/24 times 1, it stays the same. Now what I do need here is I am going to need a common denominator since I am subtracting two fractions. So I'm going to go ahead and multiply the numerator and denominator of my second fraction by 2 to the 6th power in order to get that LCD. Our next line is going to say this equals 1/1536 minus 64 over 1,536. And this is going to be equal to negative 63 over 1,536. Now, whenever you've got a fraction, you always have to make sure it's in simplest form. So we need to check to see if we have any common factors here between the numerator and denominator of this fraction. So it does look like 63 and 1,536 share a common factor. They share a common factor of 3. So we're going to divide the numerator and denominator by 3, and that's going to equal negative 21 over 512. We're going to box that answer in. That's going to be our final answer right there. All right, let's go on to number 4. The integral from 0 to 1 of 5e raised to the 6x power dx. So for this problem, we are going to set u equal to 6x, which is the exponent part. Therefore, du will be equal to 6 dx. And then 1/6 du is going to be equal to dx. So our integral is going to be rewritten as 5 times the integral of e raised to the 6x power dx. And then this can now be rewritten as 5 times the integral of e raised to the u times 1/6 du. So if we I'm going to just draw a line separating our top problem that we just worked out from this problem. So this is going to be equal to 5/6 times the integral of e to the u du, which is then in turn going to be equal to 5/6 times e raised to the u plus c. And then if we go back and substitute in place of u, we will get 5 over 6 times e raised to the 6x power, and it's going to be evaluated from 0 to 1. So this is going to be equal to 5 over 6 times, open up a set of parentheses, e raised to the 6 times 1 power, and then we're going to subtract e raised to the 6 times 0 power, close the parentheses. This is going to be equal to 5/6 times, open up a set of parentheses, e to the 6 minus e to the 0 power. Now let me explain how I got that. I'm going to point an arrow here at the exponent in the above work where we had the e raised to the 6 times 0 power. So 6 times 0 is 0, so that's going to turn into e to the 0, and e to the 0 is equal to 1. So I'm just going to go ahead and write a 1 in place of e to the 0. Close the parentheses. And here we're going to have the answer. I'm going to box that in. Okay, we're ready to move on to our second section on differential equations. Recall, a differential equation is an equation with a derivative in it. I'm going to highlight that sentence. And I'm also going to underline the words differential equation. I'm going to put a cloud around the words equation with a derivative in it. Our next sentence, to solve a differential equation means to find the original function, y equals f of x. I have underlined the words to solve a differential equation means to find, and I have boxed the words the original function. Next sentence, this involves finding the antiderivative. So that's very important as well. So we're going to go ahead and underline that whole sentence. The sentence that states, this involves finding the antiderivative. After we underline that sentence, we're going to go ahead and also underline the part that says y equals f of x, because that's going to represent our original function. And we're also going to underline in the instructions that we need to find y equals f of x. And I'm going to put a cloud around the problem, so that way we know what we need to find the antiderivative of. So example 5 says, given dy dx is equal to, open up a set of parentheses, 3x minus 1, close the parentheses, all raised to the 5th power. Find y equals f of x. So I have drawn a cloud around the derivative that was given to us, and I have drawn an arrow pointing at the cloud, at the derivative, and I have written down the words we need to find the antiderivative. So we're going to go ahead and take the integral of this derivative. So that's what we're going to start off doing. I'm going to set this up I'm going to write here y equals the integral of, open up a set of parentheses, 3x minus 1, close the parentheses, raised to the 5th power dx. So now we can go ahead and integrate this. I'm going to set u equal to 3x minus 1. Therefore, du is going to be equal to 3 dx. So 1/3 du is equal to dx. So now we can go ahead and do our substitution. So this is going to be 1/3 times the integral of u raised to the 5th power du. If we integrate this, we're going to end up with 1/3 times u raised to the 6 all over 6 plus c. First, I'm going to make my work here a little bit smaller and move it more to the left so I have more space. So we would have this equals 1/18 times u to the 6th plus c. Now we can substitute for u. So this is going to be 1/18 times, open up a set of parentheses, 3x minus 1, close the parentheses, raised to the 6th power plus c. So y equals 1/18 times, open up a set of parentheses, 3x minus 1, close the parentheses, raised to the 6th plus c. I'm going to box that in. I'm going to have an arrow pointing at it, and we're going to write down general solution right next to the arrow. When you find the solution to a differential equation, if it includes that plus c at the end, another way to refer to that solution is the general solution. Example 6. The marginal demand function for a company is given by d prime of x, which is equal to negative 1400x over the square root of 16 minus x squared, where d of x represents the number of units sold at a price of x dollars per unit. Find the demand function d, given that d equals 10,000 when x equals $2 per unit. So I'm going to go ahead and highlight where it says marginal demand function in yellow, and I'm also going to highlight d prime of x, that function, the whole function. I'm going to highlight it in yellow. So this function, d prime of x, represents our marginal demand function. If we find the integral of d prime of x dx, we're going to be able to find the demand function. It says here d of x represents the number of units sold at a price of x dollars per unit. I'm going to highlight that sentence in green, and I'm also going to highlight in blue, find the demand function d, given that d equals 10,000 when x equals $2 per unit. D of x equals the integral of negative 1400x times, open up a set of parentheses, 16 minus x squared, close the parentheses, raised to the negative 1/2 power dx. We're going to let u equal 16 minus x squared, therefore du is equal to negative 2x dx. I'm going to highlight the x and the dx in the du, what the du is equal to, and the x and dx in the integral. All right, so I'm going to also divide both sides of the du here by negative 2, and I'm going to get negative 1/2 du is equal to x dx. So I know exactly what to substitute. So my integral is going to be equal to negative 1400 times the integral of, open up a set of parentheses, 16 minus x squared, close the parentheses, raised to the negative 1/2 power times x dx. Now we're ready to do our u substitution. So this is going to turn into negative 1400 times the integral of, here we're going to substitute u raised to the negative 1/2 power times negative 1/2 du. I'm going to factor out that negative 1/2, so it's going to be equal to negative 1400 divided by negative 2 times the integral of u raised to the negative 1/2 power du. Now we're ready to integrate. So this will be 700 times u raised to the 1/2 power divided by 1/2 and plus c, and then this would be equal to 700 times 2 times, open set of parentheses, 16 minus x squared, close the parentheses, raised to the 1/2 power plus c. Therefore, d of x is equal to 1400 times, open up a set of parentheses, 16 minus x squared, close the parentheses, raised to the 1/2 power plus c. I'm going to draw a cloud around this equation right here. This is going to represent our general solution. I'm going to draw an arrow pointing towards this equation, and I'm going to write down the words general solution next to it. Oh, before I do the next step, I'm going to make the work that I did here for the U substitution part smaller. So I lassoed it and I made it smaller. I'm going to write down now that D is equal to 10,000 and X is equal to $2. And we're going to substitute into our general solution. So this is going to be 10,000 equals 1,400 times, open set of parentheses, 16 minus 2 squared, close the parentheses, raised to the 1/2 power plus C. Next line will be 10,000 equals 1,400 times, open up a set of parentheses, 16 minus 4, close the parentheses, raised to the 1/2 power plus C. Next line, 10,000 equals 1,400 times 12 raised to the 1/2 power plus C. And then our next line here will be 10,000 equals 1,400 times the square root of 12 plus C. And then we will have 10,000 equals 4,849.74 plus C. C is going to be approximately equal to 5,150.26. I'm going to take all of the work I've done for this problem, lasso it, and shrink it, make it smaller, move it slightly to the left and slightly upwards. Now I'm going to substitute here in place of my d of x equation. So d of x is going to be equal to 1,400 times, open up a set of parentheses, 16 minus x squared, close the parentheses, raised to the 1/2 power plus 5,150.26. This is my particular solution. I'm going to box that in. So that d of x represents our demand function, given that d is equal to 10,000 when x is equal to $2. Example 7. The rate at which oil is leaking from a pipeline in thousands of gallons per week is given by R of t is equal to 8.3 times E raised to the power of negative 0.015 t, where t is the number of weeks since the spill began. Evaluate the integral from 0 to 8 of R of t dt and explain what this value represents. Let's begin by rewriting our integral. So let's write down the integral from 0 to 8 of R of t, which is going to be 8.3 e raised to the negative 0.015 t power dt. I'm going to go ahead and I'm going to underline what we're being asked to do. So here it's asking explain what this value represents. So I went in and I boxed that in, and I also boxed in evaluate the integral from 0 to 8 of R of t dt. I've numbered those as 1 and 2 because there's two things we need to do here. So there's like two parts. So I've drawn an arrow here from our integral that we wrote out pointing to the right, and I wrote a number 1 to represent this as part 1. So I wrote down 8.3 times the integral of e raised to the negative 0.015 t power dt. U is going to be equal to negative 0.015 t. du will be equal to negative 0.015 dt. And then negative 1 over 0.015 du will be equal to dt. So the one that I wrote to represent the first part that we're finding here, I'm going to erase that one inside the circle here, and I'm going to write it all the way here to the left in front of the first integral that I wrote. And I'm going to lasso the second integral that I have written here, and I'm just going to move it a little bit more to the left so it lines up a little bit more nicely. Okay, I'm going to draw an arrow here to represent my next line down, an arrow pointing to the right, and I'm going to write down our integral. I'm going to write down 8.3 over 1 times negative 1 over 0.015 times the integral of e raised to the u power du. This represents all my substitutions that I've done for my U substitution to make this so that I can integrate it. So I'm going to have here, this is equal to negative 553.3 with a repeating bar over it times the integral of e to the u du. And then this will be equal to negative 553.3 with a repeating bar over it times e to the u and then plus c. And I'm going to write the plus c inside a set of parentheses, because this is a definite integral and we are going to be evaluating it, so we won't be keeping that plus c for long. So this is then going to become negative 553.3 with a repeating bar over it, e raised to the negative 0.015 t power, evaluated from 0 to 8. And this is going to be equal to negative 553.3 with a repeating bar over that. Open up a set of square brackets. E raised to the negative 0.015 times 8 minus e raised to the power of negative 0.015 times 0, and then we're going to close the square brackets there. This is going to be approximately equal to 62.57. So that's the numeric value that we get. Remember that it said here in thousands of gallons per week, and I highlighted that part in yellow. The rate at which oil is leaking from a pipeline in thousands of gallons per week. That's what our R of T represents. I've highlighted that all in yellow. Because it's saying here thousands of gallons per week, I'm just going to focus on the thousands of gallons. I've circled the thousands of gallons. I've crossed out where it says per week, and I'm just going to label this number as 62.57 thousands of gallons. And that's going to be our answer. Another way we could write this, I'm going to write here underneath, I'm going to put or. We could also write it as 1,000 gallons. So I've gone ahead and I boxed that in as our answer. Now we want to explain what this is. This is going to represent the total amount of oil that leaked in the first 8 weeks. And in parentheses, I'm going to write down in thousands of gallons. And I'm going to box that in. So there are the two parts to this question that we've answered.